Hi learners, welcome back to our lesson. In our previous lesson, we were solving problems involving transmission of pressure in liquid. I had given you some two questions and let me hope that you attempted them. I'm going to go through them. You can check whether you had scored or made some mistake, then you rectify. Welcome. In the first question, I had said, it says the figure below shows hydraulic lift. The cross-section area of smaller piston A is 5 square centimeters and that of larger piston is 80 centimeters squared. Given that the force of 100 Newton is applied on the smaller piston, calculate A, the pressure on the smaller piston. So we have here our diagram. This is small and this one is large. So we are being asked to calculate pressure on the smaller piston. So we have solution. That is 1A, pressure is equal to force over area. Force over area. Now we have force, it is here, given that a force of 100 Newton is applied on smaller piston, then the area is 5 centimeters squared. So when you are calculating, first of all, we make sure that everything is in the SI unit. So we have area in centimeters, we are supposed to convert it into meters. So you work it out. We have 5 centimeters squared into meters squared. Within the 10,000 centimeters squared is equivalent to 1 meter squared. So what about 5 centimeters squared? We have 5 times 1, then over 10,000. This is our area. This is 0.0005 meters squared. 0.005. We can still use calculator to confirm. This is 5 divided by 10,000. Yeah, 0.0005. Now, if I have my area, I have my forces here, so I just substitute in my equation. So this is given by 100 divided by 0.0005. This equals to, we have 100 divided by 0.005. So it gives us 200,000 Newton per meter squared. So this is the pressure exerted on smaller piston. Then B, the pressure on the larger piston. B. So from our previous question, we said that by Pascal's principle, pressure on smaller piston is equal to pressure on the larger piston. This implies that pressure on the larger piston is given by 200 1000 Newton per meter squared. That is the answer for the second part. And the last part, the force on the larger piston. We said, that is part C, from this general equation, pressure is equals to force over area. But when you are being asked to determine force, then force, it simply means that force is given by pressure times area. So you have pressure, area we have been given in, that is 80 centimeters square. We need to convert this one into meters squared. So converting, that is 80 centimeters squared into meters squared. So you have 10,000 centimeters squared is equivalent to 1 meter squared. So at about 80 centimeters squared. So you have 80 times 1 over 100 over 10,000, sorry. This one gives me 0.008 meters squared. That is the area. So we have pressure, we have area. So our pressure is 200,000 times area, which is 0.008. So when I multiply by 0.008. Wow, it is multiply. So 200,000 multiply by 0.00 multiply by 0.008. It gives me 1,600 Newton. This is the force that it can act on the larger piston, or the load is exerting onto that area, experienced by that area. So that is how you are supposed to work it out. We can move to question 2. Question 2. So I still have solution. Now question 2. The figure below shows part of a hydraulic machine used to lift load. So we have a load, larger piston, smaller piston, A2, A1. Then this is liquid. Given that A1 is 0.006 meters squared, A2 is 0.5 meters squared, and F1 is 120 Newton. Calculate the pressure in the hydraulic fluid. So that is Roman 1. We know that pressure is given by force over area. Now pressure exerted at A1 and A2, it is just the same by Pascal's principle. Now when I calculate this pressure here, it is just the same as pressure at A2 or in the larger piston. The question is just open. We are supposed to calculate pressure in the hydraulic fluid. Fluid is just liquid from A1 to A2. So when I calculate pressure using smaller piston, it's just simple. I will have just answered the question. So in A1, I have A1, then I have A2. Now in this case, I can say if this is now, if this is P2, then this one I can denote as P1. So I can say that P1 is just equals to F1 over A1. This F1, it simply means it is force in the smaller piston. A1 is area in the smaller piston. P1 is pressure in this smaller piston. When I calculate this pressure, it is just the same as just using P2, A2, and F2. So I have F1, which is 120, then A1, I have it. So F1 is 120 divided by 0.006. So using our calculator, we have 120 divided by 0.006. It is giving me 20 Newton per meter squared. That is the pressure. Then calculate the force that is used to lift the load, the force. So we have said that is Roman 2. So pressure on the larger piston, say P2 is the same as pressure on smaller piston, say P1. Now, this means that P2 is equals to P1, and P2, pressure P2 is just F2 over A2, which is just the same as pressure 1. We have seen it is F1 over A1. So they are asking me to calculate the force that is used to lift the load, which is F2. I can denote this one as F2. That is what they are asking. Meaning, if I want to get just F2 is given by F1 times A2 over A1. I multiply both sides by A2. So meaning that my F2 is A2 times F1 then divided by A1. Remember all these variables we have been given. We have our F1 is here. We have our A2 is here. Then we have our A1 is here. So we substitute in. We have 120 times A2, 0.5, then divide by 0.006. So when I simplify this, I have 120 times 0.5 divide by 0.006. It gives me 10,000. So we have 10,000 Newton. It is force. So this is how you are supposed to carry out this assignment. Remember, our pressure it is 20,000. Our force is 10,000. So this is how you are supposed to do it. So we have done almost 5 questions in this area, and I hope that you have understood something. So I would like to give you some 2 questions or 3 that you may attempt when you are at home. These are the 3 more questions that I have prepared so that you can attempt. The first question is that state Pascal's principle. Then the second one, the figure below represents a section of a hydraulic machine. The area of piston A and B are 0.03 meters squared and 0.5 meters squared respectively. A force of 16 Newton is applied on piston. On piston A. On piston A. So you have, this is piston A, piston B. We have the area here, we have the area I've given you. So you are supposed to use this given information to determine Roman 1 pressure exerted on oil by piston A. Pressure here. Then maximum force that can be lifted by the system, this one here. Then question 3, state any 2 properties of a liquid used in hydraulic brake. These are the questions that you are supposed to attempt when you are at home. That marks the end of our lesson in the transmission of pressure in liquid. God bless you. Bye-bye.